You've probably heard many organizations announce that they're launching a new improvement process across the entire organization. They're going Agile, doing Lean, or implementing Six Sigma, or something like that. But this is a mistake, because there is no one-size-fits-all method for everything. All methods work well in the right context, but work terribly in others. In order to work out which method is the right one for your context, first you'll need a map. Let's take the map we used earlier when looking at the very first principle, use a common language. But this time we'll use the English version rather than the one in Elvish. We decided we would build our world perception server in-house, as it's on the left of the map, meaning there's too much uncertainty about it to outsource it to others. But what method should we use to build the thing? We might look at Agile methods, as they are popular today and seem to be good at keeping costs down when exploring novel ideas. Agile focuses on fast iterations to quickly develop a minimal viable product for testing and feedback, which is then incorporated into the next iteration. Clearly then, using Agile to build our world perception server would be a smart move. It will reduce our cost of change as we work out what the thing is and how it works. But this success is a potential tripping up point. Because Agile worked well on one project, we might get seduced into thinking it's the one right method for all projects. So we start trying to implement Agile everywhere. And that's a problem. Let's explain by exploring the other component we looked at earlier, the ground positioning system, or GPS. On this map, GPS is being used by drivers in semi-autonomous vehicles, perhaps long-distance lorry drivers, using technology to take over for parts of the journey. If the providers of GPS adopt Agile methods to make improvements to their system, they might start moving fast and failing early, as these are features of the method. But how do you think the driver, the user, will feel if the GPS his autonomous vehicle is using to stay on the road suddenly starts failing due to these changes? He may not be alive long enough to give feedback that the Agile method thrives on. And this is the problem with trying to apply a single method everywhere. One size does not fit all situations. It's why the organization responsible for the GPS might be better off using a different approach to making improvements. In this case, they may use something like Six Sigma, which is great at reducing deviation in performance. This doesn't mean that they can't use Agile. They could if they were working on something innovative and on the left-hand side of the map. It's just that they wouldn't use Agile everywhere. For example, on the critical systems on the right of the map that others are depending on. It's a case of horses for courses. That is why we tend to outsource components on the right of our map, as the challenges of improving stable systems require specialist approaches. While for components in the middle of the map, there are also better approaches than doing it yourself with Agile or following the rigid demands of the Six Sigma method. You can either buy commercial off-the-shelf products that do the job for you, or if your component is your differentiator, you might use Lean methods. Because Lean is a great method for learning how to reduce waste to make your system more efficient and outputs more profitable. But again, this is a great method in the right context, in this case for components in the middle of the map, but it's weaker for components at either extreme. You should now be realizing that the right method to use depends on the evolution status of the components. For a novel component on the left of the map, you'll experiment with Agile methods, but as the component evolves and there's more certainty about it, then Agile methods become less useful. Lean methods, or buying a finished product, are more appropriate as your focus now should be on a more efficient use of the component for greater profitability. And as the component industrializes, moving to the right of the map, it's best to outsource this to experts. And if this is you, your focus should be on reducing deviation in performance, although this shouldn't stop you from experimenting on improvements in the background. And that's why you need a map, to determine which methods are best for what you're doing. However, we've noticed that this kind of pragmatic thinking tends to bring out the worst in some people who have already committed to a tribe. You see, tribes don't tolerate blasphemy against the universal applicability of their method. You just don't understand it correctly, they'll shout at you. But the point is, you don't need to understand every method in order to decide which one is appropriate. You just need awareness of the context. And remember, there is no one-size-fits-all method. It's horses for courses.